Hello, welcome to the first video. We will see if we can't make this nice and clear. At the end, you will have an opportunity to give me some feedback about what the next video should look like, but in general, this is the basic format of them. Today we are talking about atoms and how we classify them. The first thing we really need to talk about, and we've talked about it before, is the definition of matter. Matter is the stuff that the natural world is made of. Everything you see is made of matter. Everything in the picture there, the chain links, the fence, the air in between the camera and the fence, the air beyond, the building, the tree, the ground, the grass, the gravel, all made of matter. Our first month or so, probably a little bit longer than that, is going to be spent studying chemistry. So, matter has different characteristics based on how it is put together, how the elements work. There are different things you can use to describe it. Things can be hard, soft, hot, cold, dense, solid, liquid, gas. Some things burn, some things don't, right? Chemistry is the study of matter, how substances react and interrelate. Within that, we will use the word substance. A substance is a single kind of matter. It is similar to an element in that it has a specific composition, but sometimes the substance will be more complicated. It has any substance, is any physical thing that is the same all the way through, will have two kinds of properties: physical properties and chemical properties. Physical properties are characteristics of a substance that can be observed without changing it into a different thing, right? So a physical property would be the size of it, where it freezes, how it melts. That means it's 6:30. Where it freezes, where it melts, is it flexible, luster, or how shiny it is, freezing point, boiling point, how well it conducts heat, how well it conducts electricity, how hard it is, what temperature it is, what texture. We can measure all these without changing what we are looking at, is the important thing here. Physical properties are things you can measure without actually changing the substance. A chemical property is how well something turns into different substances. So, does it burn? Can we make it rust? Can we make it tarnish? Can we melt it? Not really melting. Let's stick with what they give us: rusting, tarnishing, flammability. We will talk about these more. These are going to be more helpful when we start to classify matter. So, that being said, what gives these chemicals, or these substances rather, all of these properties? Well, atoms, right? We have our first model of the atom that we started to talk about yesterday. This in particular is a carbon atom. So essentially, the number of protons and neutrons in the nucleus give matter its first round of properties, right? We've got a number of protons in the nucleus, and that is going to tell us what atom we're dealing with. This is the same as the number on the periodic table. So the number of protons in the nucleus tells us what atom it is. You can have as many neutrons in the nucleus as well as you have protons. You can have less, you can have more. This gives us something called an isotope. Let me say that again. This gives us something called an isotope, the number of protons, or the number of neutrons in the nucleus. On the outside, we have the carbon, outside of the carbon, we have the electron shell around, and that's where the electrons sit. Now remember, this particular version is sort of like a solar system, and I told you you could use this version on any kind of exam I give you. But the reality is, I have to move the screen. The reality is that electrons sort of react like this. Do I expect you to be able to draw this? No, I don't expect you to be able to draw this. But just so you know, if you do choose to draw something with big funky clouds, you can still see where the center is. This is helium. This is something with 2 protons and 2 electrons. And when you actually run tests, this is how it reacts with things. They do this by shooting photons, light beams, into atoms and getting readouts and seeing what happens. So this is actually what atoms look like when you start to do experiments with them. Now, substances that we were talking about, pure substances, elements, have different arrangements of atoms. Like I told you, because the atoms interact as sort of big clouds, it's sometimes easier to think about them as clouds. And there are three substances that we know, solids, liquids, and gases, all interact in different ways. With the atoms within a solid, all sit very close to each other. Note they are not touching, but they sit very close to each other with the electrons close to each other, pulling each other together in a very rigid, very uniform structure. They kind of look like a grid. Liquids are a lot more fluid, obviously. The atoms in a liquid do not sit together as well or necessarily as closely as a solid. They can move around a lot more. They tend to be further spaced out. But once again, because we're talking about an element, a pure substance, it's all the same atom. Gases, really far apart, right? These molecules are atoms. We're talking about atoms. Let's stick with that. These atoms can move around freely and do pretty much whatever they want. But once again, keep in mind, all the same. The last little bit I want to talk about is a mixture. See how this is set up the same as before. We have a bunch of atoms, right? Not touching. But we have two different kinds of atoms. And they're floating around with each other. You'll find generally mixtures will not be solid. Generally mixtures will be liquid or gas. And they really just are two different kinds of atoms close to each other. If you do, I'm going to put it this way, if you are asked to draw something like this, you really ought to put nuclei and electrons in this. But keep in mind, because these are different kinds of atoms, they ought to have different numbers of protons and neutrons in their nucleus than each other. You should have at least two different kinds of atoms. We'll talk about this a little bit more today. There we go.